Slope of a line. The steepness of two objects. Compute the ratio. Vertical distance divided by horizontal distance for each object. The object with a larger ratio is the steeper object. In this example, we want to show why ladder B is steeper than ladder A. So we're going to compare the vertical distance to the horizontal distance. Starting with ladder A, we want to compare ladder A's vertical distance to its horizontal distance. So we're going to have 12 divided by 6, which is 2. For B, we're going to compare its vertical distance to its horizontal distance. So we're going to have 12 divided by 3, which is 4. Since 4 is larger than 2, ladder B is steeper than ladder A. Finding a line's slope. Let x1, y1, and x2, y2 be two distinct points of a non-vertical line. The slope of the line is m equals the vertical change over the horizontal change, rise over run, or y2 minus y1 divided by x2 minus x1. The subscripts 1 and 2 show that we have an x value and a y value for our first point, and then an x value and y value for the second point. Our slope is always labeled with an m. In our drawing, we can rise up and then run over to get from one point to another. The rise is always the difference in your y's. The run is always the difference in your x's. It won't matter which point you start with as long as you start with that same point for both the rise and the run. In this example, we want to find the slope of the line that contains the points 2, 4, and 5, 10. We want to use our slope formula, m equals y2 minus y1 over x2 minus x1. Our point, 2, 4, can be our x1 and y1, and 5, 10 are x2 and y2. So now we want to substitute into our equation. So we want to start with m equals, because you always want to label your work with the correct symbol, 10 minus 4 over 5 minus 2. It's always a minus sign when you're doing slope. Then we just do the math. 10 minus 4 is 6. 5 minus 2 is 3. When we reduce, 6 over 3 reduces to 2 over 1. Now we do like to have a proper improper fraction for our slope because it makes it easier to use the rise and the run to plot our points. But you can also write the slope as 2. In this example, we want to find the slope of the line that contains the point -5, -4, and -1, -6. So we're still going to use our slope formula. We're going to let -5, -4 be our x1, y1, and -1, -6 be our x2, y2. So m equals -6 minus a -4 over -1 minus a -5. Because we have minus a -4, that's the same as plus 4. And then minus a -5 is the same as plus 5. So I have -6 plus 4, which is -2, over -1 plus 5, which is 4. -2 over 4 reduces to -1/2. So the slope of our line is -1/2. Increasing and decreasing lines. If you have a line that goes up from left to right, you have an increasing line and it has a positive slope. So you have a positive rise over a positive run. If you have a line that goes down from left to right, you have a decreasing line which has a negative slope. You can have a negative rise over a positive run or a positive rise over a negative run. Horizontal and vertical lines. A horizontal line has a slope of 0. A vertical line has an undefined slope. In this example, we want to find the slope of a line that contains the points 3, -1, and 3, 4. Then we need to determine if our line is increasing, decreasing, horizontal, or vertical. First thing we need is our slope formula. Again, we're going to let our first point be x1 and y1, and our second point be x2 and y2. M equals 4 minus the -1 over 3 minus 3. So 4 minus a -1 is the same as 4 plus 1. So that gives us 5 over 0. Since 0 is in the denominator, our answer is undefined. Our line is vertical. In this example, we want to find the slope of the line that contains the points -5, 2, and 1, -6. We're going to determine if the line is then increasing, decreasing, horizontal, or vertical. We're going to use our slope formula. We're going to let -5 be x1, 2 be y1, 1 be x2, and -6 be y2. So m equals -6 minus 2 over 1 minus a -5. -6 minus 2 is -8, and 1 plus 5 is 6. Then we reduce, we get -4 over 3. So since our slope is negative, our line is decreasing. Parallel lines. Two lines are called parallel if they do not intersect. L1 and L2 are parallel lines. They have the same slope but different y-intercepts. If line 1 and line 2 are non-vertical parallel lines on the same coordinate system, if the slope of the first line, M1, is equal to the slope of the second line, M2. Two lines are called perpendicular if they intersect at a 90-degree angle. So line L1 and line L2 are perpendicular lines. Slopes of perpendicular lines. If lines L1 and L2 are non-vertical perpendicular lines, then the slope of one line is the opposite of the reciprocal of the slope of the other line. So M2 is going to equal -1 over M1. So what that means is if I have a slope M1 equals 2, then M2 is going to equal -1 over the value of M1, which is 2. An interesting thing about multiplying the slopes of perpendicular lines, if I have 2 times -1/2, then I multiply them, I have -2 over 2, which is -1. I can also test to see if two lines are perpendicular by multiplying their slopes, and the result will be -1. In this example, we'll be using the indicated slopes of L1 and L2 to determine whether the lines are parallel, perpendicular, or neither. We're assuming that L1 and L2 are distinct lines. The first thing that we notice, M1 is 2/5 and M2 is -5 over 2. So they are not the same. We can rule out parallel. If I were to take the 2/5, flip it, change it from positive to negative, I want to verify that that is M2. So I can say that the lines are perpendicular. I can also take 2/5 times -5 over 2, multiply them together to get -10 over 10, which is -1. This also shows that my lines are perpendicular. In this example, we're going to use the slopes of L1 and L2 to determine if the lines are parallel, perpendicular, or neither. M1 is 7, M2 is also 7. Since our slopes are the same, we can say that our two lines are parallel. In this example, we're using indicated slopes of L1 and L2 to determine if our lines are parallel, perpendicular, or neither. M1 is 3 over 8, M2 is 8 over 3. 3 over 8 is not equal to 8 over 3, so we can rule out parallel. 3 over 8 times 8 over 3 is equal to 24 over 24, which is a +1, so we can rule out perpendicular. So our answer to this one is neither. The slope of a line is rise over run. y2 minus y1 equals x2 minus x1 and is always labeled with the letter M. An increasing line has a positive slope. A decreasing line has a negative slope. Parallel lines have the same slope. Perpendicular lines, the slopes either multiply to be -1, or you take the first slope, find its reciprocal, change the sign, and you have the perpendicular slope.